I think I'm going to start off today with something that's going to be forever known as the alley maneuver, just to check where I am. Well, hey, all right. So present and future, the deprogramming language. Those two words usually go in that order, but I'm going to do something different because I was going to do it in that order. I'm going to start with the future first, then I'm going to go back to the present. No one's laughing at the slide. If you don't watch Doctor Who, it's on you. Right, so where we want to go, this is, the heavens part, the angels are singing, things are good. We have a minimal recompiling theme, and all you have to do is type a few things. Compiler already knows what's going on. You get your results back, sub 20 millisecond iteration cycles. Because, as we know, I hate waiting even 20 milliseconds. The lot of views that are okay with 5 seconds are wrong. Fix the language without breaking users' code, so we can move to the future without, forgetting the past. The second version of Phobos, and the third, and the fourth, and what have you. Phobos releases only a header, even though we don't have those, for multiple reasons. More attribute inference, so we don't have to keep typing safe, pure, no GC, const, I don't know, whatever, pure, more stuff that may even come in the future, and things like that. So we want to go here. This sounds like a good future. I want to go there. I wish I was up here in a turtleneck describing one of these things, doing something sexy, and then going one more thing, and the crowd goes wild. But I don't get to, unfortunately. Because how do we get there? Well, we need to crawl before we can walk. And so we need to take care of the present first so that we can move into the future. And so where are we now? Well, we have a GC, so we tell people we're memory safe. That's one of our selling points. Except, when we're not. Because you can pass pointers to the stack and things blow up, and that's not good. And why that's not good? Because we're trying to convince people to use D instead of whatever they're using now. And if we're not safe, they could just go to Java or Go. And if we have a GC and some people think that they can't afford a GC, they might go to something else. So we need to tighten this down. And we tell people, well, it's fine. D has a GC, but it's optional. You don't have to use it, except it's hard. And if we make it hard for people to not use GC, they're not going to do it, and they're going to do something else, especially if they're already having to do hard work themselves. Why would they subject themselves to that? And very justified complaints, I think, about unfinished features. Just keeps coming up in the forums. People keep mentioning it. When are we going to finish X, Y, and Z? So let's tackle that. I think that needs to be the priority. So what is our unfinished business? We have a lot of preview switches that we turned on, well, introduced anyway, to enable people to check out new features in the language, but they're all still there, basically. And that's not good. It's not good optics. Not for us, not for anyone else. We keep getting questions about shared, which I did a few days ago. So shared's up there as well. We have a bunch of code in Phobos under std.experimental, and it just keeps staying there. Again, this doesn't look good. It doesn't feel good. So what I think is important is to give a sense of momentum that we're moving forward, that things are happening, and that things are working. And whatever else anybody of you, can come up with, please let me know what else that is unfinished that we need to tend to, and I'll put it in a list of items that are to do. So the previews. What I need to do here is go through all of them, basically. And by we, I mean me. And I think that we haven't done a good enough job of checking, even after they get implemented, if the runtime or Phobos even compiles, because it turns out sometimes that's not true. So after implementing them, we need to check if those compile, if the projects end up compile, because otherwise we can't turn them on. What's the point? Check also file issues in these preview switches before we can move forward with them. What are the bugs that people are seeing so we can fix them first before we can move forward? And then go through each one of them, see if they have merit, especially if they've been there for a few years. Was this a good idea or not? Did it work? And decide whether or not to transition or just to bin it. And one thing that I think has been working quite well is instead of just transitioning and breaking everybody's code, of course, that's not what we want to do, is we annoy them first by printing deprecation messages that would have been printed if they had used the preview. So I think this is working really well for DIP 1000. We're getting messages now that would be printed if it were a DIP 1000 violation, and it just annoys the user, but the code doesn't break. And they can get rid of those messages by using revert. So that way, they're preparing, either they fix the code so the messages disappear, or they use preview, they don't get annoyed anymore, and when we do the transition, nothing will break because the old behavior is going to be preserved. And then, of course, after some while, we switch the default. And again, anybody could use revert, and they get the behavior they did before. Nothing breaks. It's unlikely we're going to get rid of the revert because it doesn't cost us much, and it's better to have people have the code still work going into the future. So what do we still have left of the preview switch? We have dip 1008, and there's a bug that Matthias told me about where it still allocates for the stack trace. So we need to look into that before we can do anything with it. There's fieldwise, which has been there for a while, and I've already started doing the work to make that the default. And then all these other ones are value ref param. There's a bug stopping us from doing it. No shared access is important because of shared, and there's a bug stopping us from even printing the messages, which I filed as well, so those need to get fixed. And then those are the three there. Now, shorten methods isn't too big of a deal because it's very new. That's okay. The problem is when we have preview switches that have been there for years, and it seems that nothing's happening, so I am making sure that something will definitely happen. We can't just let them be there in limbo. So shared. Keeps coming up. And it's unclear to me exactly what the community means by unfinished. Because of the preview switch I just mentioned, which is no shared access, if we fix the bugs and we get that in, as far as I'm concerned, share's done. You can't access things, you can't read, you can't write. That's exactly what you want shared to be. Shared is supposed to be something that tars and feathers a type. Just make it icky, don't like it, can't touch it, right? And that's what we want. You can't do anything with it, good. Because then you have to cast it away, lock a mutex, do whatever you want, but then you're responsible for doing that in your section of code. So I don't know what else we're supposed to do with it, but I think that focusing on shared anyway is misguided. I don't think people should be using shared a lot. I don't think they should be even writing that word. I think it's akin to modern C++ and writing new or delete. They're not going to get rid of those keywords. That doesn't make any sense. But if you're writing them, 99.9% of the time, you're doing it wrong. Why are you writing new and delete? You should be writing either make unique or make shared, and then RAI takes care of the destructor for you. It's kind of similar with shared. You shouldn't be using it directly. I think what we need is library help to do it. So something similar to the library I wrote called Fearless and or structured concurrency in Phobos. So what I'm saying is we need structured concurrency in Phobos. That's it. Use that instead. And to give an example of library support for doing it instead of doing it yourself, I wrote a library called Fearless. Given the fact that nobody has filed an issue in it, nobody's using it, unfortunately. I didn't even compile the new DMD. I had to fix it last week. But it at least serves an example of what I'm talking about in terms of use a library, don't use it directly. So it was shamelessly inspired by std sync mutex from Rust. That's why I called it Fearless, Fearless Concurrency. Ha ha ha. Nobody laughed, I know. And also, you know, I got the feeling if I put this up on the slide, somebody would say like, oh God, there's Walter and Átila chasing Rust again. Look, here's the thing. Composition exists. When the first TVs came out, nobody looked at a hotel putting TVs in the rooms and then another hotel copying them. It's like, copycats, I'm not staying with them. Nah, I'm gonna go no TV, that's great. When something's good, you need to compete. And that's just the way it is. And this is a good idea. And in fact, the first time I learned about mutexes, it was in C++. And it didn't make any sense to me, because it was by convention. I had a variable called foo, and then a foo mutex. And because they were named similarly, I knew that this went with that, and I had to lock this. That doesn't make any sense, right? I could completely do the wrong thing. Nobody's going to stop me unless somebody catches it in code review. And we know and have known now for decades that convention-driven development does not scale. So don't do that. And dip 1000 helps limiting access to the shared state. So just like Sebastian talked about yesterday, dip 1000 helps with this because you can control access to it. And so that's what Fearless does. So it's the opposite of bring your own mutex. You don't have to. It gives the mutex for you. So the idea is that you have your own type struct foo. Obviously, silly example has an int in it. And then you call this function that creates an exclusive access to foo. So you have to give it the type you're trying to construct as a template parameter, and then the arguments to construct it. Now, this is important because you don't want to pass it something you've constructed, because now you have an alias to it, and so does the other thing. You want exclusive access. That's why it's got exclusive in the name. So instead, we construct it for you, give us the arguments, we'll make it, and nobody else has access. And so the code here is scoped with curly braces just to show how it works. With the scope, this old int pointer is only there because the declaration comes before, so that we can look at it, the example later. The way you use this is you call lock, which of course is going to lock a mutex that's hidden from you inside this new type that wraps yours. And for the duration of basically when you lock and then it goes out of scope, only you have access to it as guaranteed by DIP 1000. So I can not only access, but change the value of the I inside the foo. So this is D, so we wrap it really well. This new type has basically the same access, the same types as it were, has an I as well. You don't have to go xfoo.something.i. And then we have a local there, which is pointed to int. And then we statically assert I can assign that pointer to the internal representation I have, because it doesn't live longer than that, and nobody else has access to it. But I can't assign it to something that does live longer. And again, DIP 1000 helping us with this. And this is an example of what I mean by don't use shared directly. You don't see shared here anywhere, but you can't send it to another thread, because otherwise what will be the point? And here you see, a function that takes a thread ID, you call receive from standard concurrency, and then you take the exclusive, you have to lock it again so you can do anything with it. So you can, for instance, increment I, and see, there's no shared anywhere. Now the thing is that the exclusive bank foo is an alias to a shared type, but you don't see the shared keyword anywhere, because why would you want to keep typing shared all the time? The whole point of this type is to be shared, so don't do it. So the focus, so shared is a building block. It's a fundamental thing. Yes, it needs to exist, but don't use it directly. We need to enable library writers or something that goes into Phobos to be able to wrap access to it in a way that makes sense, instead of manually requiring everybody to cast away, lock a mutex, cast away shared access, etc. That doesn't make any sense. So what about std experimental? It was a good idea. Let's try out some stuff that we don't know if it's ready yet or not, because otherwise, if we put it directly in Phobos, then it's basically ossified and we can't change it. So let's put experimental first. We make no guarantees about APIs or anything like that. We will break it, don't rely on this. But it doesn't seem to have worked as intended, because things get stuck there and have been for a long while without anything changing. And again, I want to combat this feeling of things aren't going forward, things aren't changing. Things are. Let's get this, working as intended. I did get checked merged into std months ago, so because that was easiest, because it was just one module. But I think that code.dlang.org is a better alternative, which is one of the questions I got asked that I said I'll cover that in my talk. Just stick it in there first. That way people can try it out, file issues, change it. Use semantic versioning to break API if you want, and there you go. I mean, look at what happened to allocators. We had to change the API and make a break and change. What do? We put the old API into Phobos so people could depend on it. So it goes to show that I think that this is probably the best idea. And I think it worked really well with std sumtype. It was there in Phobos for quite a while. It went through a lot of versions and issues being fixed, and then we put it into Phobos. And I think that is probably a better method, and also because nobody needs to ask for permission, right? Somebody wants to go into experimental, it's going to be this whole thing. It's probably not going to get merged. A lot of people are going to have opinions. You can just put things in dub. People like it, they'll use it. If they don't, they don't, and there you go. And maybe we could even put Phobos in dub and exploit this whole semantic versioning, right? Make breaking changes, stick it up there, and then people use whatever version they want. They can declare in their dub SDL or JSON which version they want, and things will work. So I think this is an idea worth exploring, and the more I think about it, the more I like it. And fortunately for me, I'm the one that gets to decide, so yay. And so going through the things we have in experimental, we've got typecons here. And unlike the other two that I'm going to talk about, it's tiny. It's got a tiny little module that I didn't even know existed until I basically went into the folder and went to see what's in there. And what I need to do is basically just go through all of it and see if it makes sense. And in all likelihood, it will, and just stick it into std and call it a day. Because we already have typecons, so just stick it in the existing module. I'm not even sure when this got written. I think it's ancient. Logger. What happened is I talked to Robert because he wrote the library, and I asked him if anything needed doing. He said it did. Fortunately for me, he went and did it instead of myself. There were some comments. There was a bit of back and forth. I had to fix one of the issues. I looked at all the bugs in issues.dlang.org, and there was no showstoppers because the issue here would be if something required an API change, then that would be blocking to put it into std because we don't want to do that. Nothing was like that, so it's fine if we put it there and fix bugs later. And I managed to get it merged, I think, Friday or Saturday last week. So that's good, that's done. Now, there are open questions on Allocator, and the questions I have here was basically a similar process I did with Robert, in which I asked Andre, since he was the one that wrote it, what's stopping us from merging this as is, and so he had several things that he said needed to be decided or looked at, etc. One of them was, what should be the default go-to allocators? So I want to use allocators. I can't afford a GC because I've profiled, of course, right? Right. And what do I do? Like, what should I reach for? Is mallocator what I should do? Like, how do I use this? And we'll look at it in a little bit. And also, because of the design we have now, how do we synchronize access to the global allocator states? Two threads are trying to set the allocator. What do we do with that? Because right now, there's no protection whatsoever. And then how do we manage the allocators themselves? You know, who allocates the allocators? Who watches the watchman? And that could get meta quite quickly. So is reference counting a way to get around this? Do we do it in an ad hoc fashion? That's a very good question. I don't know. But we also have this showcase module in which we have basically, because allocators is a bunch of building blocks. So it's like Lego, right? You're supposed to take these building blocks and put them together, and then you have your allocator based on that, which I don't know if everybody's understood, because in the wild, they keep writing their own allocators, and it's not how you're supposed to use it at all. So in Showcase, we have a few examples of this is what you're supposed to. Here's one I made earlier for anybody that watched Blue Pizza growing up in the UK. Or maybe I'm too old and nobody remembers. Okay. Anyway, here's one I made earlier. Here's an example. This is the kind of thing you're supposed to be doing. And Andrew said that we should have more examples of classic high-performance allocators in there. The thing is, I don't know what he means. And I'm just going to read some papers and see, you know, what examples exist out there. So for particular kinds of use cases, here's some allocators. So basically more examples in there, which is easily fixable. I don't think this is a showstopper to merge. It's an addition anyway. And what's the relationship between allocators and the GC? How far can the allocator interface, where it be the runtime or the compile time one, affect or be able to model the garbage collector as we have it? And what is the porcelain of allocators? Like, what should the API for a regular user look like? How do I use this? How, you know, what's the high-level usage? So, going through them. The go-to allocators. After thinking for a little bit, I realized that it cannot be the allocator or process allocator. For those of you who do not know, the allocator is a function that returns the allocator for the current thread, and the process allocator returns the allocator for the whole process. Both of those default to the GC as is now. Now, here's the issue. If you're going to use this, this is basically global access to an allocator, right? Now, imagine I have a vector that I wrote in a library, and I changed the allocator to my custom allocator because I profiled, and I know that this thing is better than allocating the GC. Okay, I create a vector, then I change the allocator, it goes out of scope, and oops. That's not good, is it? That's at least visible. I just did that, and that's dumb. What if somebody else does it in a different module, in a different package, in a different thread? This is a thread local one, but what is a process? Oops. So I don't think this can work.
Hey, Átila, we've got a comment from Ian here. He would remove a SBRK region from experimental allocators before considering anything else.
Okay, that's a good point. Ping me later so I don't forget. I can't merge this right now anyway, so it's not like, you know, we're in a hurry. Unfortunately. And so that's going to be an issue. Now, why do we even have this anyway? Because you see this vector, it could be interchangeable with any other vector with a different allocator, right? which sounds good until you realize that this could be a problem. Because you have the issue, for instance, in C++, where you have a vector with a different allocator. They're not the same type, even if they have the same contents. So how do you use them? How do you add one to the other? And it's a complicated issue, and right now I don't have the answers to it, but I do know that this can't be the right way, because I should not be allowed to do that. And that happens right now, right? I wrote a vector in a library, and if I do that, boom. So what are the solutions to this, since this can obviously not work? Well, we can maybe try to allow setting the process allocation only once for the whole process. You can only do it at the beginning. Now, it would be great if we could do this in, say, a static constructor, and somehow we disallow doing it afterwards. But I don't know how to do it within the confines of the current language to guarantee that. Because maybe two different, static constructors do it. I only want to be able to do it once, be able to check that it's only set once. Because that would work, right? I can have an allocator for my application because I know that this is what I'm going to need for the whole process. It only got set once at the beginning of the program. It can never be changed again, no problems. And likewise, only allow setting the thread allocator at thread creation, but how do I hook that in? I spawn a thread, and I'm not entirely sure, but maybe we can change things in such a manner that I could write code to guarantee that. Maybe you can only allow replacing the allocator if no memory is allocated, because that's fine, right? I have an allocator in memory, I can't free anything badly. The GC has a facility to tell you how many bytes have been allocated in the current thread, which could help with this, but what if it's a process allocator? Well, maybe we could add that to the GC stats as well, but that requires some surgery. So that's another idea to mitigate this problem and still have the goodness of an allocator interface so that different vectors and what have you would have the same type. And or only allow setting the allocator to the current one's GCs, because if you have allocated memory but it was on GC heap, do we care? It'll just live forever. It'll get collected if anybody else allocates in GC and you run out of memory. So these are some ideas I'm toying with to be able to get around this problem. Synchronizing setting global allocator state. I think the solution here is easy. Just don't let it happen. Don't let people do that. And aliasing makes it worse, right? Because the problem that Andrew was worried about was you'd have two threads trying to set the allocator state, and then you'd lose the original allocator. But I could take a reference to it somewhere else. I mean, that vector problem could be fixed by me calling the allocator and storing it. And so aliasing is bad. And for the classic allocators, all I need is really examples. And again, additive features, so not a big deal. But yeah, it would be nice. Allocates in GC, and after thinking about it for a while, I'm not sure we should even try mixing the two, because conceptually, yes, the GC is an allocator. It allocates memory. That's literally its purpose. But it has guarantees that no other allocator has. If I see a T star in safe code in D, I can store it. I can pass it around. I don't need to care how long it lives. It lives forever. It's fine. Right? If it's a scope T star, different story. I'm only borrowing it for a little while. It's a book I've taken from the library. I need to give it back, and that's it. T star, on the other hand, in safe code, either it came from the GC, or it's a pointer to a thread local. Either way, it lives forever, and you're fine. So those things have guarantees. If I get a T star from an allocator, I don't know what I can do with it. So should we mix the two? I'm not sure, because then we lose that safety we get from the GC. If I treat a pointer I get from allocator the same way, things start getting complicated really quickly, because now you have lifetimes in ownership and all of those things. So I'm not sure that we can reconcile the two. And what should the porcelain be? Similarly to what I said about shared, the focus should not be on users using allocators themselves. They should just pick one that works for their application and will be faster, right? Because that's the only reason you're going to use a custom allocator to begin with. Otherwise, why'd you care? Or because you're trying to constrain memory usage, I guess, something like that. Users shouldn't be doing that. You shouldn't be calling allocator.allocate. We should have library types. So we should have facilities for them to use it in a high-level manner in which they don't need to care that much. So like a vector, like a reference counter smart pointer, like a unique smart pointer, things that take care of those things for you. All you have to do is select the allocator, or in the case of if you're using AutoMem, you don't need to because the default will be the allocator. You just need to set it, and all of the other vectors that you have will be created using it. And there you go. The focus should be on high-level APIs. Nobody should be using malloc and free. We cannot be telling people that want to use D, oh, I can't afford the GC. It's fine, call malloc and free. No. Use this instead. Nobody does new and delete in C++. Why are we telling people for malloc and free? That makes no sense. Stop doing that. And no GC, because we have interfaces right now, like actual interfaces, runtime polymorphism, and none of them have no GC in the functions. And I think that it's an issue because, look, the GC resistance is a people thing. It's not technical. It's because people believe they can't. And we're not going to change their perception. It's really hard to persuade people. So let's just accommodate them. Oh, you can't use GC? That's fine. It's this way, sir. And since it's a perception issue, I think no GC is important for that because people want to have compile time guarantees. It's good that you can go in a Reddit thread or Hacker News and say, oh, you can't use no GC? The GC, that's fine. Put no GC on me. You're guaranteed. So I think that it's important that the interfaces have that in them as well. And given what I said about the GC and reconciling it with allocators, it's probably the way forward because otherwise, like, trust me, it won't allocate in GC. I don't think it's going to cut it. But it's lacking, so I think probably we need to add them there. And so we go back to the future. Q Hugh Lewis plane. Header-only Phobos is an idea we've been toying with. Obviously, Phobos v2. Trust me, I wish I'd be working on that instead of all of this, because that's sexy. This is not. Additions, more attribute inference, and a lot more stuff that I probably won't have time to talk about anyway, although I am blowing through this. Turns out adrenaline makes you talk faster. Who knew? So header-only Phobos, again, header, don't have those. So the problem is, well, sometimes the problem is that we have a distributed binary, and it's not built with the same flags as the users, and that's caused a lot of problems in the past because Phobos is built with one set of flags. You built your project with a different set of flags. Oops. For instance, we had a lot of times when people were using dash unit test because they were testing their code, they would see Phobos in a different light, as it were, because all the version unit test blocks would be now triggered, and then template emission happened, and there were linker errors because obviously Phobos wasn't built in unit test mode. And we ended up with a hack in the compiler that's only being recently removed. Thanks, Martin Kinklin, for that, because it was increasing compile times ridiculously. And that's just to fix that one issue. So maybe what we need here is to just basically distribute Phobos as a source library. And if we put it on dub, it comes for free, source library target type. You build Phobos as you're building your project. Then you can use whatever flags you want. And so that might fix some problems we'll be having. So that's an idea. Phobos v2, I basically need to take ownership of this and see it through. So, I mean, one of the main goals is we want to remove auto-decoding. And so we want to have if all we do is do that, then that's enough, I think, for version 2 of Phobos, one that doesn't have auto-decoding. So we want to make breaking changes, but people can just use old Phobos as they want and keep the same behavior so their code doesn't change. We want to be able to share code between them, so we don't want to copy things wholesale, and because then that makes a maintenance nightmare. Now you have to fix things in 2 different places, or 3 if you have Phobos v3, etc. A focus on OGC. Now, by this, I do not mean that nothing can allocate ever. Look at you guys chasing other languages again. No. It means Phobos shouldn't make allocation decisions for the user. You can allocate all you want. Just stick the array on it. But that's your business, not Phobos. And saying this, there's resistance, and I think it's odd because, for instance, map is one of the most used functions in Phobos. It's no GC. Not necessarily no GC, but if your Lambda doesn't allocate, neither does map. So that's what we're talking about when we say no GC here. It's allow the usage of no GC code, not mandate it. And also, don't make decisions for the user. they can allocate what they want by calling .array or whatever they want. I mean, they can pass a lambda that allocates. That's their business. But focus on that. And as Walter's been mentioning as well, there's a lot of code in Phobos v1 right now that deals with 3 string types, and it's a mess, and conversions between them, and we should just eliminate all of that and only use string. Yes, I understand that Windows exists, convert it. Take a string, convert it to double string, pass the pointer, convert it back. That's going to be a lot easier than maintaining this mess of code. So those are the goals we want, but then there are technical challenges. How do we get this to work? There's template mixins, there's the approach that Andre's having right now. All of them have drawbacks, and I just need to sit down, look at it, and figure out a way in which this can work, that we can do all of these goals and achieve them. Addition is something I mentioned before that I really, really, really want, because we're going to make new mistakes. It's not just the ones we've made already, we're going to make new ones. As my PhD supervisor once said, an expert is someone who's made every possible mistake. So, made a lot of mistakes, we don't know how to make those anymore, but we're going to make new ones, and we need to plan for that as well. And we want to fix the ones we've already made, but we don't want to break users' code. Addition is a great way to get around this because it's an opt-in per module decision. The default will be the old language, and then you can write new modules in the new language, and they'll have different semantics. Now, Walter thinks that we can't change everything in the language because of complications of importing and things like that. And okay, maybe we can't change everything. Maybe we're stuck with some of those things. That doesn't mean we can't change, we can change some things, and so we probably should. I mean, ideas off the top of my head, make private the default, for instance. I can't see how that is impossible. Obviously, safe being the default, things like that. I think that public being the default seemed like a good idea, and things are a lot easier. You don't need to type a lot, and the API is right there. However, as we've learned, when public is the default, people start depending on internal details of your code because you did mark it private. Now you can't change it. And I think the worst thing you could do in software engineering is make things harder to refactor. Things should always be easy to refactor because you're going to need to at some point, unless your code isn't being used. And it's probably, for us to do this, we're probably going to have to do some complicated compiler refactoring to enable this. But just because it's hard doesn't mean we shouldn't do it. I really think that this is the way forward, so we can just move forward, don't break users' code, and have our cake and eat it too. Attribute inference. I mean, I don't like writing safe no GC pure no throw const as much as anybody else. It's not nice, and it does clutter things visually, and I can't make everything a template. So, given that in practice, most D code seems to be open source in the sense that hardly anybody uses DI files and distributes that with a binary, as used to be the case back in the 90s. People would sell software, give you the headers, give you the precompiled binaries, and it was closed source. But in practice, it seems that doesn't happen too much in our community. That doesn't mean we won't support that, but given that, a lot of the time, you're depending on a dub package, and the source is right there. Infer, no? That'd be good. And I did say that, the other day I wrote C++, and it was great not to have to write all those stuff. It's not quite like that in C++ either. That's an example of, modern C++ code. There's a lot of noise there, too. And at least we don't have to write const.expr and everything, because everything is implicitly const.expr. And so, the summary and my run-through talk is that the priority right now, much to my chagrin, should be in fixing bugs and finishing the features. Whatever it is that we have loose strands, tie them up, cut them, burn them, something. Just don't leave them there. And that should be the priority right now. That should be what I should be looking at and fixing so that then we can move forward. After we've cleaned house, then we can look to expand. I think this is really good for the community as a whole as well. Give it a bit of oomph and show them that we're fixing this and we're doing this the right way, I think. And that the focus should be in high-level usage instead of low-level building blocks that nobody should be using in the first place. Again, we're not going to get rid of them. D is still a systems programming language. We need the low-level details to be in there. because somebody needs to write those libraries, and they need those building blocks to be able to do that. But the focus should be on enabling high-level usage for the users and having experts write these libraries so that you don't have to, right? Don't spawn a thread, use Sebastian's code. And to be able to do that, because I only work on D part-time, and even if I did work on D full-time, I can't fix all of the bugs myself. And sometimes I'm not even, familiar with the code base enough to be able to fix that bug in particular. And if I have 1 day per week, by the time I've loaded the context in my head, it's gone, and now I have to wait 7 days. So I'm asking for help fixing these bugs, especially the ones that are preventing us from, for instance, turning the preview switches on. Anything that's gating that, please help out if you can. There's a hackathon tomorrow, so there you go. And question time, which we have more time for.
Well, applause first, I'm sure. And we do have a comment from Ricky. This is going back to the process allocator and the allocator thing. If you want to assign a global only once, an atomic compare and swap will do that for you.
Yeah, but then you can reassign it later, no?
Yeah, well, I mean, I guess if you're going through an API, then you know the constant that you're trying to swap it with, so you can do it that way, but...
Right. Back there.
Sorry. You said you talked about opt-in per module. I'm not sure, maybe that's what you meant, but can preview itself be per module? Because we have a code base of thousands of modules. Enabling it in the CLI means we have to transition thousands of modules at the same time. And it's not a one developer project, so having each developer transition their own code and then eventually just enabling the CLI preview sounds like a more doable approach for a huge project.
Yeah, it's an interesting idea. I mean, you're using a build system, so it's going to be hard to set compiler flags for just that one module.
Something like a pragma preview or something.
No, I like the idea. That makes sense.
Sorry, it was actually the same question.
Like how many unnecessary non-node GC functions are there actually in Phobos? You always say to measure first. Is that actually a problem to be solved?
Yeah, so we had a project in which we're actually going to do that by analyzing all the unit tests that weren't Node.gc and then having documentation that would show you which functions are Node.gc or not. Unfortunately, it didn't get finished. But that was something that was being done. In fact, I should go bother him. Where is he? And take that code and finish it. Yeah, there he is. Give me the code.
It's not only Node.gc that sometimes prevents to use parts of Phobos. Will there be a push to remove liberal usage of TLS inside Phobos?
I wasn't aware that that was an issue, but if it is, then I would say that yes, we should.
Synchronized isn't, thread safety isn't always about like protecting access to or preventing memory corruption. Sometimes it's about sequencing access to a data structure and preventing logical errors. And synchronized this and synchronized classes are currently used for that, but synchronized forces shared on this. So what's going to happen that going forward?
Good question. I don't know. But yeah, that needs to be thought about.
You talked about making Phobos Node.gc friendly. And by the way, I don't think it's only a perception problem. Maybe it's 90% a perception problem, but
Sure.
yeah, we have benchmarks and we have real issues.
But you measured.
Yeah, we are using like Node.gc on a huge chunk of our code base. But one thing I noticed about Phobos is that a lot of the GC preventing Node.gc in there is just the edge cases checking and then throwing an exception. Is there any plan to make exceptions more friendly to Node.gc code? For example, throwing structs instead of allocated classes, or something like that?
Well, there's DIP 1008 that tries to address that by making the, throwing exceptions no GC. But unfortunately, that's one of the ones that has a bug gating it from, because I want to turn that on as well, because that is exactly one of the last few cases in which things are happening there. And there's no reason for it, so.
So that's, I guess, a gating thing for making Phobos
Yeah,
much more noticeable.
we need to fix this issue with the stack trace allocation thing and then turn it on.
Yeah, we got a quick comment from the chat. It's not only no GC, Phobos using a thread local storage liberally prevents it to be used in more situations without a D runtime. So.
As we got the comment from Guillaume earlier.
Sorry?
Great minds.
What I think should be done with the allocation is you pass the allocator in as a parameter to when you use it, and there should be no global allocator setting. That's the first thing. And the other thing is, in my talk, I talked about using chain to do things like defer allocation and push it up the stack. So instead of passing an allocator down and then concatenating your arrays, you return a chain or a range. Then up at the top level, there you decide what allocator you're going to use to convert the chain to an array. And you have an extra parameter, but it solves the problem.
Well, the vectors I have there do actually have the ability of taking an extra parameter in which you pass the allocator in. The reason why that API exists is because of the whole problem of different vectors with different allocators not having the same type. That's what that's trying to solve.
Okay. I'd have to think about that.
So I think we were the first and probably only company to use preview switches in production. We implemented preview in. And when we did so, we added that to our dub JSON, and we had weird bugs. And we were wondering why, because we ended up realizing that dub was not passing the flags down to your dependencies. So right now, if you're using preview, it's probably actually not working because the flags are not passed down. We have a hack in dub for that, and I don't think many people are aware of that. But for me, it was a sign that the preview approach actually doesn't work unless you're the one implementing it.
I think that's more of a dub issue, because if I'm not mistaken, if I put preview in my library, it passes that to the dependents for some reason.
No, it does not. Unless you put it on the dependency. You can add deflags to the dependency and just give it whatever you want.
Right. Again, I think this is more of a dub thing than, I mean, if you manually call the compiler, you could put the preview wherever you want. But of course, most people don't call the compiler manually, so we need to fix the issue in dub.
Hello. If Phobos were in dub, then it would have a version, right? And probably every library would end up depending on some version of Phobos, right? And then you end up, I think Haskell sort of has their own special version of dependency hell where they end up having, it becomes really hard to import libraries because they depend the last time the author used that version or updated their version, it's an older version. And even though there's not an incompatibility functionally, just because the version numbers haven't changed and someone specified a specific version, things become very difficult to sort of
Yeah, that's a good point. I think if we did that, because we haven't done it yet and I haven't decided if it's a good idea yet or not, especially because there might be issues I haven't thought about. If we did that, I think that we should tell people that the default should be version equals star and just use whatever, unless you actually care what version of the standard library you want. But yeah, thinking about multiple standard library versions in the project is already making me go,
Right, it would have to be, because essentially when you have the standard library just come with the compiler, you get sort of, you get the star, right? It's essentially just a star, right? Like, and it basically works except when it doesn't, and you figure it out and move on, right? But you don't have problems that are specifically just fake problems because they're just numbers.
Yeah, no, I understand what you mean. Good point. Need to add that to a list of possible issues.
Isn't it kind of a pity that exceptions are kind of the case where you would want to use the GC? Like, you don't want to structure your code. You structure your code around ownership or resources to some degree, right? It constrains how you build your code base. And the exception path is not the thing you want to structure your code base around. And therefore, it's a perfect case for just give it to the GC. And most people are like, oh, I can't use the GC. You can't use the GC on an exception path? Really? But because I actually personally have written code where I want it to be no GC because I want to catch, oh, whoops, that closure accident, there's a closure there that causes an allocation that's going to be really slow. But like, I definitely want that weird edge case where, like a file handle disappears or something, like some OS problem. I still want to throw an exception there. I don't care about performance in that case.
Somebody came up with the idea a few weeks ago of considering throwing exceptions as no GC, because who cares?
But there is some precedent with the debug and pure,
sure.
Is it? Or
right,
one
right.
of those, yeah.
Well, the problem with that is people might be catching them and logging them, and then you will generate garbage. Imagine you're running a server, and if the program's going to terminate, yeah, who cares? But what if it's not? And you can't tell because it could be caught somewhere else.
Yeah, I think in the end it's probably not very interesting as a compile time thing, no GC in the end. It's more the sort of thing that you, like looking at the GC profile of your program and seeing, oh, there's no entries in the GC profile. I'm doing it right.
I understand that, but you're at DConf. I don't need to convert you.
Fair.
Right? I need to proselytize it to other people. Like, your soul will be saved. No GC.
All right, we can do one more question. Who's got one more question? There we go.
I can already feel the pressure. So I brought up this last year as well. I think we should start building Phobos and all our tools with dub, because we're trying to tell people, hey, use dub. It's the go-to package manager. But then when they look at our source code, we don't use it ourselves. So I think that doesn't make like a really good selling point, right?
Yeah, it's a good idea. I mean, if I never have to edit 3 make files to add a file to Phobos again, I'll be very happy. Because that's insane. Build all of the things. The thing is there, build it. If it weren't to be built, then don't put it there.
Yeah, and I know, so I think like there were some comments that it has some performance issues or something, but I don't see this as a showstopper. Maybe exactly the opposite. Like if we start using it, then we'll have a bigger incentive of fixing it and improving it rather than the current state.
Yeah.
Thanks.
Okay, and that's the end of question time. So surely you guys got everything answered now, yes?
If you didn't, just, annoy me later.
Yeah, he loves it. Anyway, applause.